A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, the instructor for NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Our today's lecture will discuss about the different aspects related to the checks which are made to ensure the construction quality of bituminous bound courses, which will be under the module 7. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. As we all are aware, these are the highly important layers. Bituminous bound layers are highly important layers for a flexible pavement structure. So, which are constructed as bituminous bound base course, bituminous bound binder course or a bituminous bound wearing course. So, they form a backbone of your flexible pavement structure. So, it is very important to ensure that a good quality construction of these layers are done, so that we can ensure a long lasting durable pavement. So, it says that bituminous bound layers constitute the primary structure components. These are the one which adds highly to the structure strength of your flexible pavement, contributing significantly to their overall strength and performance. They play a major role. These are the top layers which are going to bear the maximum distresses due to traffic and change in the climatic conditions also. Ensuring quality during production and construction is essential. So, see, it is very important to ensure that the things goes in the correct manner as per the required standards, because it is good to control, as we always says, precaution is better than cure. So, similarly here also it is very important to ensure the checks during the production and construction itself, because thereafter rectifying those defects especially in bituminous bound layers becomes very challenging, and it is a very costly affair also. So, it is important that we do a good amount of checks so as to regularly monitor the quality of our bituminous mix production as well as its construction. Ensuring quality during their production and construction is essential to safeguard the structure integrity and the long term durability of the pavement. And in recent years, need for stringent checks and quality control measures has increased substantially, because we are experiencing a very high growth of traffic volume, and the requirement is also increasing in terms of we want long lasting payments, we want payments which have low maintenance and which provides a good smooth surface with lesser requirement of maintenance. So, in recent years, the need of stringent checks and quality control measures has increased substantially, driven by escalating traffic volumes and the growing demand for enhanced service life and durability of roads. So, we will be having a discussion of many codal provisions, including some of them are listed here, which includes the Handbook of Quality Control for Construction of Road and Runways, the Manual for Quality Control in Road and Bridge Works, guidelines. The IRCS P11 has been merged with IRCS P112. Then we have the guidelines on measuring the road roughness and norms, specifications for road and bridge works, our orange book, specifications for dense graded bituminous mixes, IRC 111. So, as we discussed in earlier courses also, it is very important to understand the design, specifically the alignment of your road. So, it is very essential for everyone to understand the drawings, to understand the aspects which are shown in the drawings in terms of the center line, in terms of the presence of curves, in terms of the width which has been shown, in terms of the ROW which has been acquired, in terms of the radius of any curve which has been shown, and if some discrepancy is found, it can be pointed out, because all these designs are ensured at various levels, but then also if one figure out some discrepancy, he can very well have a discussion with the designer to get those things incorporated, and there may be certain challenges which one may encounter during the course of construction. So in that particular case also there may be some requirement to be made in the design, in the specifically the alignment. If that is there, then again it needs to be discussed and a prior permission has to be taken up. Now, as I mentioned, the drawings gives a good details specifically at varying changes with respect to the profile of your road, and it gives information about the cross section. Here a typical cross section has been shown, where you can show there is a median which is there of 1.5 meter width, then there is a carriageway of 7 meter width, followed by a paved shoulder and earthen shoulder. It shows the right of way also, proposed ROW which is there. In addition to this particular one, it gives an information about the layers, individual layers, which is your subgrade layer is there, then granular subbase course constructed in one layer only, then we have wet mix macadam base course, layer 1, layer 2. So wet mix macadam total thickness 250 mm has been constructed in 2 layers, followed by your a bituminous base course which is DBM of 60 mm thickness, followed by your wearing course of bituminous concrete of 40 mm. So the center line is marked, taking care of the levels at the top of my carriageway. In terms of the center line, I can work out the levels. You can see the cross slope which has been shown. It is on the carriageway, it is 2.5%. When it comes on the shoulders, it is there you are showing it is showing 3%. In addition to this particular one, you can see the side slope which has been shown as 1 vertical and 2 horizontal. Along with it, you can very well see that the material which is used in granular subbase course will serve the purpose of both drainage cum filter layer. So it has been extended to the edges, and thereafter on the top of it there is a selected earth fill. This is usually the subgrade soil which is preferred to be used in selected material. On the top of it again a compacted granular material is there, then you have these WMM layers which are there. So it is very important to understand. So the drawings, the cross section, then only you can work it out. So if I have from my horizontal alignment, I have the levels for my center line at different changes, I will work out what will be the levels at the bottom of one particular layer, at the top of that particular layer, so that I can ensure the surface levels in the field. So first I need to ensure the specifically the levels in the field to get the correct horizontal alignment. So the horizontal alignment is to be ensured with reference to the road center line as indicated in the approved plans and drawings. So important that whenever you refer, all drawings are approved drawings. There may be some preliminary drawings are also available, may not be approved. So those drawings need to be vetted, and the one which you are going to refer is the approved one. This process involves here in case of horizontal alignment verifying both roadway geometry and the edges of the various pavement layers against the designed center line. So I will work out the levels with the center line considering the width on say on each of the layer. From the cross section I will work it out the edges of each layer. So this is very important, which needs to be arrived from your horizontal alignment. Adequate control of the horizontal alignment is possible, and for this particular process you need to precisely mark your center line. So a good surveyor team is required. You need to be acquainted with the use of total station, with the use of dumpy level to ensure the levels at different layers. You can see these pegs are marked here, then a string may be there. So these are normally used to put up to have a check over the surface levels. Now this can be done. So adequate control of the horizontal alignment is possible if the center line is precisely marked. So for that you have the benchmarks, you have the temporary benchmarks in the field using reference fillers placed on both sides of the center line at the regular intervals, and they should not get disturbed during the course of your construction. To ensure adherence to the design, the edges of each pavement layer should be ensured. As I showed there, the edges of a granular subbase course gets extended to your side slopes, whereas the edges of your base courses and the upper courses are having a different extent of. So this needs to be verified from your cross section and then need to be checked with your surface levels at the levels at those layers. So it says, and to ensure adherence to the design, the edges of each pavement layer shall be ensured in relation to the center line before construction, and for this particular one you can put pegs, strings, or any other tools can be used. And as per the MORTH requirement, it says the edges of the carriageway when it comes on the top, specifically the wearing course, the bituminous concrete course, or stone matrix asphalt, or semi-dense bituminous concrete, which are preferably used as wearing courses or surface courses, shall be correct within the tolerance of plus minus 10 mm. So this is what very important when the top carriageway is considered. The corresponding tolerance, as we have seen, this can be only achieved if we are following the tolerances from the bottom layers, because otherwise we may fall short for the width of our carriageway. So we need to ensure it, and at every moment it should not be, since you are given a tolerance of plus minus, that does not mean at each layer you will go for a negative tolerance only. No, this is the range. That does not mean you can use it. You have to use it judicially, and this needs to be permitted by the engineer in charge of the project, so that finally when on the top you are able to reach it, it should fall within this particular range. Now then, the surface levels, as I mentioned during the course of construction itself, and it is always advisable that during the course of construction itself, before the construction and during the course of construction, it should be ensured. So this exercise goes simultaneously. You can see this is a surveyor, they are also engineers, so any one of us can look into and ask them to install the staff, your total station, and you would prefer to have a continuous check over it. And as I mentioned in our previous lecture, for the compaction exercises, for the laying exercises, for the number of passes, we need to have a trial stretch. Normally a trial stretch at least of an area of 100 square meter is preferred, so that you can get an idea about how the compactions are there, in what manner the compaction process, laying process, what should be the loose thickness when it is coming out of the paver. So loose thickness also you can monitor that, whether the loose thickness, definitely the pavers have sensors, they follow the levels which will be given through them using the pegs and the strings. So these are all sensor pavers. So with respect to that, they will construct your surface courses, but then also because these are machines, we need to ensure whether they are working properly or not. So the levels of the constructed bituminous bond course shall not vary from those calculated with reference to the longitudinal and cross profile. As I mentioned, once you have the top surface levels for your center line, you can work it out for any layer at any part of it, at any width, what should be there. So those calculated with reference to the longitudinal and cross profile of the road shown on the drawings as directed by the engineer, beyond the tolerances should not be beyond the tolerances, and what the tolerances are there, which are given by MORTH specifications. It says when you are constructing the bituminous bound courses, the tolerances should be within plus minus 6 mm. So you can understand that here these are very strict quality control checks, specifically which are required when you are looking into the bituminous bound courses. Now in addition, there may be, as I mentioned, for edges tolerances also, and also for surface levels, it should not happen that the tolerance is going in one direction. That doesn't mean a tolerance, that means a fault is happening. So it says that the negative tolerance for wearing course shall not be permitted in conjunction with the positive tolerance for the base course. So I mentioned in the previous lecture also, if two layers are there, this is the usual thickness which is to be constructed. So this is your base course, and this is on the top you have the wearing course. It should not happen that on the top of it I am doing in this particular manner, I have the tolerance for the base courses are positive one, and the tolerance for the wearing course is negative one. So overall what is happening, my wearing course thickness is getting significantly affected. So this should not happen, that I has to take care, and that is what it is stated in guidelines, that the negative tolerance for wearing course shall not be permitted in conjunction with the positive tolerance for base courses. And what it specifies if the thickness of former is thereby, because if the thickness of bituminous concrete gets reduced by more than the following limits, specifically it says it should not get less than 4 mm in any case when it is bituminous, when it is a bituminous wearing course of thickness more than 40 mm. So, even for 40 mm it can be of 50 mm, 55 or 60 mm. In those cases when it is more than 40 mm, this overall thickness reduction because of greater thickness of base courses and lesser thickness of your wearing course should not affect the thickness more than 4 mm. And it says specifically when this is for thicker ones where more than 40 mm, if it is less than 40 mm, it should not affect more than 3 mm. So, there the tolerance is given in the earlier slide I showed that plus minus 6 mm, but that does not mean in addition to this particular one this check is there, because if you are doing it for base courses, positive tolerance is there, negative tolerance for wearing course, effectively the thickness should not get reduced by 4 mm and 3 mm respectively for the different wearing course thicknesses. And see, this is the paving operation which is going on. So, once the paving operation is done, so I will simultaneously make as soon as the compaction goes on, I can make some checks for the loose thickness also, and as soon as the section gets compacted I can immediately proceed with my say checks at some random places, so as to ensure if some fault I am able to figure it out, I will try to get it rectified before more length is getting constructed. So, for checking compliance with the above requirement for bituminous wearing courses, measurements of the surface levels shall be taken on grid points, usually because we will form grid points so as to ensure that the entire section is captured in a good manner. On a grid points placed at 6.25 meter along the length and 0.5 meter from the edges and at the center of your pavement. Now, in addition to the surface levels, we also look for the surface evenness, or we can call the surface regularity. So, the measurement and checking of surface unevenness is mainly done by a 3 meter straight gauge, or we call it as a rolling straight gauge, and there are IRC 111 dedicatedly deals with the dense bituminous coarse mixes, whereas MORTH gives an overall picture of all different type of mixes. So, IRC 111 says here that the maximum permissible surface unevenness is 6 mm. Now, because two conventionally used hot mix asphalt as a wearing course are your semi-dense bituminous concrete and bituminous concrete. Along with nowadays stone matrix asphalt is also getting quite popular. So, the statement has been mentioned that the surface unevenness permissible limit is 6 mm for SDBC and 5 mm for BC in the longitudinal profile. So, when you are using in parallel to your center line, this should not go beyond this particular one, 6 mm for SDBC and 5 mm for BC. And in transverse it says 4 mm for both in transverse profile. Now, the maximum permissible frequency also of surface unevenness in a 300 meter length. Now, because we will do multiple measurements. So, it says that if you do measurements of 300 meter length in longitudinal profile, it should not go beyond these given limits. So, here you can see for bituminous concrete wearing course, for an unevenness in the range of 3 to 5 mm, it should not go more than 15 numbers of. So, along with it, it is a limiting value of 5 mm is given, but in addition to that it says that you should not have more than the range of unevenness in the 3 to 5 mm more than 15 in number for a 300 meter length. So, it further controls the surface evenness. Where the surface unevenness falls outside the tolerance, if it is going say 20 number of you are having 3 to 5, and because it is a bituminous concrete wearing course, this case, in either case the surface is low or high. So, the justification may be, you may say that I am putting up more thickness, so it can be accepted. No, even for whether it is low or high, because it is related to surface unevenness or surface regularity. So, it says whether it is high or low, the full depth of the layer shall be removed and replaced with fresh material compacted to the same specifications. Now, this, as I mentioned, becomes very challenging. So, it is very important to ensure that it goes prior to the construction of it. We need to ensure what is the levels of your base courses. So, and we there itself will see whether the base courses are having positive tolerances, then we will warn them that the wearing course should not go with negative tolerances. And in addition to that, we have to make this continuous check for your surface evenness. Now, along with it, MORTH in a similar direction mentions that maximum allowable difference between the road surface and underside of a 3 meter straight gauge placed parallel with or at right angles. So, when we measure the longitudinal as well as the transverse profile, it says 3 mm for a bituminous pavement. This allowable difference can be maximum 3 mm for a bituminous one, especially bituminous pavement surface or a bituminous wearing course, and 6 mm for bituminous base course. So, again this is very close to what we have from IRC 111, and as per MORTH 2013, the longitudinal profile when checked with a 3 meter straight edge or a moving straight edge along the middle of each traffic lane. This is highly specified because now you have constructed the wearing course. So, we prefer that when it has to be checked along the center line of each of the lane, middle of each traffic lane shall conform to the permissible surface irregularities. So, finally, when the surface is there, wearing course or carriageway is there, it specifies the irregularity, and it says that if a 4 mm irregularity is there for a length of 300, then it cannot be this particular one surfaces of carriageways and paved shoulders. So, it says in 300 meter you cannot have number of surface irregularities on national highways, it cannot be more than 15, and in case of surface irregularities on roads of lower categories, it can be 40. So, there we can see that for a length of 300 you cannot have more than 15 number of irregularities which are present there. So, this needs to be further ensured. So, this is how we check for the surface unevenness and regularity as per our given standard specifications, and these are there for some we have bus laybys, we have truck laybys, we have some service areas may be there, or for bituminous base courses. So, for bituminous base courses you can see similarly in the case of 4 mm where it was for wearing course in a 300 meter length instead of 15, now it becomes that the allowable permitted number of surface unevenness can be 40 when you are counted in this particular one. So, this needs to be further checked, and this is for 4 mm what number of irregularity can be there. So, you have the quantum of the irregularity, the length in which it is to be ensured, and the number of how many of these irregularities can be permitted. Now, if there is some, as I mentioned, if there occurs certain irregularities, then the surface needs to be rectified. So, what it says that the current codal specification says for bituminous courses other than wearing courses specifically, that means not for the wearing course, we can have a binder course, we can have a bituminous bound course, bituminous bound base course. Where the surface is low, the deficiency is usually corrected by putting up a fresh material by applying a suitable tack coat, because existing is a bituminous one, and compacted as per specifications. This is a quite challenging task. But where the surface is high, specifically with base courses or binder courses, then it says the extra thickness in the affected layer is preferably removed. That becomes challenging. So, you need to have some milling machines with you so as to mill to the required thickness and replaced with fresh material and compacted to the required specifications, because when you do, it may not be possible to do up to the correct depth. So, it says if it is high, then it has to be removed first, and then you have to come up with your correct quantity of material. And in most of the cases, the entire thickness may have to be removed, because it is, if you do not have a milling machine, it is very difficult to correct for a given depth. For wearing courses, now it comes for the wearing courses where the surface is high or low, the full depth of the layer shall be removed and replaced with the fresh material. So, this becomes more challenging when you are having these varying course mixes. These are very costly mixes. The cost of material is high, the cost of production and the cost of construction is high. So, if one needs to remove it, it becomes very challenging. So, that is why always better to ensure these levels, specifically surface unevenness and the surface levels well before and during the construction. In all cases where removal and replacement of a bituminous layer is involved, the area treated shall not be less than 5 meter in length and 3.5 meter typically a width of a lane. So, that minimum area also. So, you can see a treatment has been going in a small area. This is a milling operation has been going on. This is a regular laying and compaction operation is going on. In addition to this particular one, specifically when bituminous bond course is where the top course is constructed, wearing course is constructed, we need a smooth riding surface. So, to ensure the riding quality, the surface should not be bumpy, there should not be waves which makes your ride bumpy. So, for this particular one, specifically when it comes on the wearing courses, your bituminous concrete surface courses or any other surface course, we need to ensure for the road roughness also. So, road roughness refers to the irregularities in the pavement surface that negatively impact vehicle ride quality and user experience. You might have observed on some of the older roads that it gives a bumpy ride. Specifically, there is some wavy sort of a structure is there. So, when you drive at higher speeds, you experience, even when you drive, if those are closely spaced, when you drive at a slower speed, you can experience those bumps or the wavy structure. So, it influences not only comfort, but also vehicle delays, because you can't drive at the design speed, fuel consumption is high and maintenance cost increases. So, it is always preferred that you get a good riding quality. From user point of view, it is always important to have a good riding quality, a smooth surface and a safe surface. So, the term smoothness, that is why there is another term which is very frequently used along with the roughness is a smoothness. They want to refer that the surface should be as smooth as possible in that case. So, they can be interchangeably with roughness, as both describe the pavement characteristics, same pavement characteristics we are trying to refer it. And why this usually it can occur, the road roughness may be good enough in the initially just after the construction, but in due course of time you might experience that the roughness or the smoothness has reduced or the roughness has increased, the bumpy nature has increased, because there may be some structure defects which may be occurring, there may be some consolidation which may be happening, some occurrence of potholes, cracks, all those things makes your ride rough in that case in coming years. So, road roughness is mainly a result of either the built-in irregularities. So, there are already some built-in irregularities. If you are ensuring, you are not able to ensure the levels properly, your surface regularity, you are not able to ensure the surface evenness, then that definitely gets reflected on the top and you have a bumpy ride. Or due to some construction defects, deficiencies, so these are deficiencies, or may also appear on road surface due to consolidation. If the loads are very high, some of the layers which are not properly are compacted during construction may get compacted, some may get over compacted if traffic is more than that projected one, or the axle loads are quite higher than the one which were considered in the design. So, in those cases you may have this kind of bumpy ride. So, now to ensure this particular one that you need to have a smooth surface, we normally go for some measurements and we call them as roughness measurements. So, one of the a quite popular equipment which is used is a bump integrator. So, it measures the bumps in a given length with reference to a standard frame. It measures the vertical bumps when it travels on a road surface, so as to get an idea about the road roughness, and this gives us a quantification of the road roughness in terms of the roughness index. So, where the project specifies this surface roughness requirements, there may be certain low categories road where these roughness requirements may not be specified, but otherwise in most of the cases they are specified for higher categories of roads, and mainly specified currently in India is specified through IRC SP 16 which is to guidelines related to the road roughness, that we get in terms of bump integrator value. So, the roughness index is measured and it is mm per kilometer. So, the roughness is measured by a calibrated bump integrator. This is a typical, this is towed by a standard vehicle and run at a standard speed at the center of your lane. So, here one important aspect is you have to do calibration of this equipment regularly. Nowadays many other simultaneously more precise equipments are available for measuring the road roughness. Portable equipments are available for measuring the road roughness, but still this is one of the most popular one. So, in all equipments it is important to ensure that they are well calibrated. So, we need to do the calibration with some high precision equipments, specifically like dipstick is there. So, with those ones these the bump integrator can be calibrated so that we get the correct readings. The measurement shall be taken at the center of each lane for a minimum completed length of 1 kilometer, because it has to be run at a certain speed of around 32 kilometer per hour. So, we need at least a stretch of 1 kilometer length. Once the laying is completed, then we go this particular one. So, the typical this measurement we can do at any period of time. As I mentioned, the roughness may be quite low, the surface may be smooth immediately after construction, because if some defects are left in underlying layers, they soon get reflected in due course of time in coming 1, 2, 3 years. Many a times these defects are such that they get reflected during the course of construction itself. So, if the roughness increases of the surface, so any period of time during the service life of the pavement we can measure this particular one, and then we need to ensure whether this surface is good enough for users or it needs some certain rectification. So, the typical maximum permissible values of surface roughness measured determined through a bump integrator for surfaces with the dense graded bituminous mix is certain limits have been specified as per IRC 111/2009, which says that if you have a wearing course of BC, this your surface roughness index, which is in terms of mm per kilometer so how much is the roughness in 1 kilometer of length, it should be for a bituminous concrete wearing course. For a good means nearly this is a possible when you have a newly constructed one, and in the initial years of service life you always prefer to have a roughness in lesser than 2000 mm per kilometer. And as I mentioned, in due course of time, if the roughness increases because of any of the structure defects or consolidation or cracks or potholes, then if it falls in the range of 2000 to 3000, we can, so a newly constructed one may have something around 800 to 1000 or 1200 mm per kilometer one. So, if there are certain, if this comes in the range of 2000 to 3000, we call that the surface is having an average roughness, and if it is more than 3000, it is a poor surface. So, that triggers at what moment we have to initiate with the any repair and maintenance for these surfaces. So, always we prefer for a newly constructed one definitely much lower to this 2000 value. Now, in the addition to this particular one, there are a good number of requirements. As I mentioned, during the course of production and construction, it is very important to control the qualities during that course of time. So, what can be done is the different aspects which can be checked, ensured during this period of time. MORTH also specifies, IRC 111 also specifies that the mix grading can need to be ensured. As I mentioned, there may be a dust going out of the exhaust. So, whether we are not losing the fines beyond a prescribed limit. So, we need to ensure whether what is coming from the cold bins finally in case of your drum mix plant. So, you can take out where once it is going for storage silos or at that moment of time, or before it is entering into the drum, you can from the cylinder conveyor you can pick up a material for the entire width of your conveyor, and you can ensure whether the gradation is okay or not. Then after once the mix is produced, thereafter you can take it out. When you take it out at that particular aspect, it has been coated with the binder, so you can extract the binder, you can get the binder content also. So, they specifies how many number of times you need to ensure this particular one, like mix grading. This is important part. One set for individual constituent, because there may be certain changes which may be there, because the plant will be run for laying the bituminous base course also, binder course also, wearing course also, and all will be having a different composition. So it says that one set for individual constituent, if the job mix is not changing up, even what may happen in due course of time, what stone quarries you are using or from where you are getting the aggregates, the gradation may change in due course of time. So you may have to change your job mix formula. So you have to run your plant after a certain period of time with different combination. So that is what it is important, that one set for individual constituents for mixed grading and mixed aggregate from dryer for each 400 tons of mix, subject to minimum of 2 tests per day per plant. So if you are having, say, one plant may not be sufficient enough for the project which is ongoing. So if different plants are there, you may have, this is required for one plant in that case. So you have to do every day, you have to monitor the mix grading, and at least it says at least in 400 tons you have to do for each 400 ton, or at least 2 tests per day. Then for the regarding, once we can have these mixes, specifically stability and void analysis of mix, including theoretical maximum specific gravity of loose mix. So the simultaneously for this particular mix, you can ensure the loose mix can be taken and to be ensured for your specifically the theoretical maximum specific gravity. It can be compacted in the laboratory again with the binder content, with the gradation which is available, and to see what is the stability which we are getting. This we discussed during the course of bituminous mix design. What is the strength it carries, what is the load it has, what is the flow value, how much is the density we are able to achieve out of it, what is the void content at the given number of compaction blows. So we are trying to ensure whether that combination is now able to give you what you have designed, and simultaneously you can have samples from your bituminous mat which had been constructed and compacted also. So from there also you can have those the compacted mix. You can core that particular mix, bring it to lab and ensure for density, stability and flow values. So there it says subject to minimum of 2 tests per mix per day per plant. So this is again, and then moisture susceptibility. During the design part, we have seen that for the mixes, what we ensure is one, the volumetric parameters, which were your voids in mineral aggregates, voids filled with the bitumen, your air void content was there. Those were the volumetric parameters, your density was there, and then mechanical parameters were your stability and flow. In addition to that, we measured the resistance towards moisture induced damage in terms of the moisture susceptibility. So tensile strength ratio was measured. So we can see whether the produced mix is giving that much of resistance towards moisture induced damage. For that particular one also, it says one test for each mix type whenever there is change in the quality or source of coarse or fine aggregates. As I said, there may be one quarry which may be able to supply you coarse aggregates for a particular period of time. It may stop, or there may be a short of aggregates. And another important aspect, if you are getting aggregates from 2 different quarries, so this also needs to be very well ensured in the at the plant level, that which source is getting utilized. The job mix should have been derived from that particular source only. Density of compacted layer, once the construction is going on, simultaneously you will, for say 1 test per 700 square meter of area, you can do it at a smaller interval also, and there also again you need to do minimum number of tests to ensure, because the slight variability will be there. So the acceptance criteria is there to ensure the density in the field. Binder content, as again we need to look that one set for each 400 tons of mix. It is the costliest component, and that needs to be ensured. It plays a major role in the performance of bituminous mixes, and it is a very costly component. So always we need to take care that the right amount of binder content which we recommended in the job mix formula is getting incorporated in the actual mix or not. Now similarly, as we did the density measurements for the other layers, we can do the density measurements for bituminous matte also. We can use the nuclear density gauge or non-nuclear density gauge to measure the densities there in the field. So this can help us to ensure that the compaction pattern which we are following is giving us the required density or not. This can be ensured at that particular moment of time, and as mentioned, the acceptance criteria for test on density is at least 3 minimum tests has to be conducted. Marshall stability, if I am looking for, so I am for samples, I will take at least 2 minimum samples, and then they will be subjected to the condition which was there in case of other cases also, when we looked into the density check for subgrade courses, also granular courses, that the mean value of the number of samples which are there for density is not less than the specified density plus this is 1.65 minus 1.65 number of square root of number of samples times the standard deviation. So this is the same as we did in the case of other courses. Now what I can do with nuclear density gauge, with these density gauges, I can cut down a core, I can determine the density of these mixes in the laboratory by different methods. We have water displacement methods which are there, some vacuum sealing methods are there which can give us the density of these. So then I can ensure whether with this density whether it is meeting the requirement for that the amount of compaction which is required. So checks, in addition to this particular one, another important check is to ensure that whatever gradation we have initially planned for the combined aggregates and binder is getting ensured at the plant or not. So a regular check has to be done for this particular one, and definitely in a laboratory it is a very controlled one. At plant a small amount of variation will happen, so but that should be within a permissible range. So for different sieve sizes different permissible ranges are given because they affect in a different manner. You can see this is one which has been taken for dense graded mixes from IRC 111, which says that if a mix is to be used as a DBM and if the mix is is having particles of 19 mm or larger, 13.2 or 9.5 mm, 4.75. So whatever percentages we have arrived during the job mix formula, the variation should not be more than this particular one. So you can see very well for varying coarse mixes, bituminous concrete and semi-dense bituminous concrete, for on each sieve these are more stricter compared to the one which we have for DBM, which can be used as a base and binder course. So and as it goes down, specifically for finer materials, the ranges are reduced, the lower values of ranges are there, so they play a more significant role, and if a small change is there, they affect the performance of your mixes. So here you can see this is only a very small, specifically the finer, the fillers where 75 micron is there, 0.075 mm, only a variation of plus minus 1.5% is allowed, and then binder content is there within a range of plus minus 0.3%. Mixing temperatures, again it mentions, so you can do this check at the plant. You can take out the loose mix specifically once it comes out from your pug mill or from a drum mixer in case of drum mix plant, and you can ensure these compositions are there. In addition to this, other quality control checks will be there with respect to the aggregate requirements, binder requirements, which are further we will discuss when we will discuss the quality control and quality assurance part of bituminous bound courses. So these are some of the important discussions which are points which are required to ensure a good quality bituminous construction of bituminous bound courses. Thank you so much.